I said, chapter 4, you're going to get a lot of proofs. I will try to do several right along with you, okay? But this is the start of chapter 4. So chapter 4 is going to deal with congruent triangles a lot, but we're going to just start with congruent figures in general. Congruent figures. Basically, if figures are congruent, they have the same size and shape. Okay, so if they have the same size and shape, they are considered congruent figures. That can look like a lot of different things. It means your figure could undergo what's called a slide. So if I have a rectangle like that, if I just slide it to a new spot, but it's the same size and same shape, those are congruent figures, okay? So that's called a slide. That's fine. You're allowed to slide with congruent figures. You can also turn. So if I have this triangle and I rotate it so that it becomes this triangle, as long as it's the same size and the same shape, it just turned, it's still considered congruent figures. Okay, so you can do a turn. Or the last one that you can do and still be considered congruent figures is it can flip. So if it was that and it becomes this, right, it just flipped over. Sorry, that wasn't my best work. But a flip is fine. They're still considered congruent because they are the same size and the same shape. Okay. So we say when we have congruent polygons, they have congruent corresponding parts. That means if I tell you two triangles are congruent, the angle over here that corresponds to the angle on this triangle are going to be identical. They're congruent. Okay, the sides, if this side has a length of 2, then this side is going to have a length of 2. Okay, so all the parts of the figure are going to be congruent. They're going to match up. Okay, Noah, are you with me right now? Okay. So here's what, let me just show you what that looks like. If I give you these two polygons, let's just pretend they're congruent because they don't really look congruent. Actually, I can't even pretend. That's just a bad line. We'll leave it like that. So if this is A, B, C, and D, and this is H, I, J, and K, okay? If I tell you that figure A, B, C, D is congruent to H, I, J, K, that means everything about them that matches up is the same. And here's the beauty of it. You don't even need to see the picture to know what things are the same, okay? For instance, I can look at my lettering here and my lettering here, and I know that my first letter has to match up with my first letter. So angle A is going to be congruent to angle H. Okay, I don't need the picture to be able to tell that. The order they give you in your figures is the order that matches up. So A is congruent to H, so angle B is congruent to what? Angle I, okay? Angle C is congruent to angle J, and so on and so forth. Angle D is congruent to angle K, okay? But you can also do it with segments. I can also say that segment AB is congruent to what segment? HI, right? The first two letters with the first two letters. Now, you can look at the picture and do it that way, but I don't recommend that that be your end all, because sometimes pictures are a little bit deceiving. Where you think they're congruent is not where they actually are. I would say stick to the lettering. Go with the order the letters give you. So if I said segment AD, you would say that's congruent to what? HK, right? It was the first and the last, so you do the first and the last, HK. All right, questions on that? So you're just matching up the corresponding parts, okay? And if you can do that, it's gonna help you a lot with proofs down the road. Okay, so this is like example 1. I'm not going to do a separate example 1 problem. We'll just call this example 1. Example 2 here. If I give you these two triangles, and here's a good example of where you need to be a little bit careful with your lettering. So if this is A, B, C, and D, E, F, and I tell you that this is 30, and this is 30, and I tell you that A is 76 degrees. Okay, so we know this information. If I were to say that triangle ABC is congruent to triangle DEF. Okay, right now you should be able to tell me every missing angle. Can anyone tell me angle C, first of all? 76. It's not 76. 74. It's 74, right. So here's the deal. A triangle has to add up to 180, right? So if this is 74, then you 74, 76, and 30 adds up to 180. Okay, so we know that triangle. Now here's where you have to be a little bit careful. I want to know angle F.
76. Oh, 74.
Look at this, right? Angle F, the third letter here, corresponds to what letter on my other one?
C.
Angle C, okay? That's why I say you have to be a little bit careful here because it looks like they might be isosceles, but they're not, right? If this is 76 and this is 74, C corresponds to F, so this has to be 74. What is angle D?
76.
D would be 76 because D is the same as A. So you look at angle A, 76 degrees, that means D is 76 also. So don't just look at this because this can be deceiving if we don't know either one of these yet, right? It looks like maybe F is 76, but when you stop and really look at it, based on the letters that I give you, what matches up, okay? Do you need to move? Questions on that? Okay, then here's your first kind of, this isn't technically a proof yet, but the first thing that we're going to do proof-like, okay? Example 3. Is going to ask you, are the triangles congruent? And then they're going to say justify your answers. So that's why it's going to look a little bit like a proof because we're justifying why we're doing what we're doing. But technically I'm not telling you exactly like what you're proving and giving you a given, all that. So it looks a little bit different than a proof, but really you're proving something right now. Let's say this is our picture. Uh-oh, I ran out of room. So this is A, B, C, D, and E. And I give you BC is 4, CD is 4, CE is 6, AC is 6. These two are marked congruent. Angle A is marked congruent to angle E, and angle B is marked congruent to angle D. Okay, so the question is, are the triangles congruent? In order, at this point, we don't know any shortcuts, okay? In this chapter, you're going to get a ton of shortcuts. But right now, we don't know any shortcuts. So we're just going to say, how do we know triangles are congruent? Has to be all of their corresponding parts are congruent. So that means all three of their sides are congruent and all three of their angles are congruent. And if you can say that, then we can say the triangles are congruent, okay? So in this setup, the rule is whenever something's marked for you with hash marks or with arc marks, that is considered given, okay? So that means for my first step, I can say angle A is congruent to angle E. I can say angle B is congruent to angle D. And I can say AB is congruent to DE, ED, doesn't matter what order you put that in, okay? So I'm allowed to say those three things because of the markings. We call that given. So your reason for number one is it's given, okay? Step two, I know two other sides are congruent. How? They have the same measure, right? If it's 6 on one and 6 on the other, because they are equal in measure, they are congruent. So we would say that BC is congruent to CD. The reason being that the length of BC is 4, and so is the length of CD, right? They have the same length. You can do the same thing with AC congruent to CE. How long are those guys? AC is 6, CE is 6. So because they have the same length, they are congruent segments, okay? So now look at our checklist here. We said all three angles and all three sides have to be congruent for the triangles to be congruent. So we have 1, 2, 3, okay? Our sides are marked off. We have 1, 2 pairs of angles. What's our missing angle pair? Vertical angles, right? You're going to say, and I cannot call this angle C congruent to angle C. Remember, if they share a vertex with another angle, you have to use how many letters? 3 letters. So you're going to say angle ACB is congruent to angle ECD because of vertical angles. Okay, so now that's my third check for all the angles are congruent. So when they ask, are the triangles congruent? Your answer is what? Yes. We would say technically if we're doing it as a proof, triangle ACB is congruent, and you got to name them in order. So if it's ACB, what triangle is that congruent to? ECD. By the definition of congruent triangles. In order for them to be congruent, you need 3 sides and 3 angles congruent. 3 pairs of sides and 3 pairs of angles. Okay? Questions on that? Okay, I have one theorem and one more proof, and then we're done. So the theorem we're going to talk about right now is called the third angles theorem. And you'll use this one from time to time, third angles theorem. The beauty of it is the name kind of tells you what you're working with. But basically what it says is if 2 angles of one triangle are congruent to 2 angles of another triangle, then their third angles are congruent as well. So we'll just write it out. If 2 angles of one triangle are congruent to 2 angles of another triangle, then their third angles are congruent. Okay, here's what I mean by that. Let's say I have these 2 triangles. Basically, I'm saying if this is ABC and DEF, if A is congruent to D and B is congruent to E, then by the third angles theorem, I know that angle C is congruent to angle F. Anyone know why we know that? Because the other two are congruent. Because what? They add up to 180, right? If they both have to add up to 180, and we have the same amount on both triangles so far, there's only one amount left for that third angle, right? So that's the third angles theorem. You'll use it from time to time, okay? Okay, so let's do one more proof, and then we'll call it good, and then you'll have some time to get started on this and see how it goes for you. Can I go past this third angles theorem? Are you still writing? Okay, I'm going to start writing the given information down here. So this is example 4. It says, given that LM is congruent to LO, MN is congruent to ON, angle M is congruent to angle O, and angle MLN is congruent to angle OLN. Okay, so that's everything that you're given. They're going to ask you to prove that triangle MLN is congruent to triangle OLN. And then you get a picture. Here's your picture. And you're going to finally get to see where some of these properties that we've learned about come into play. All right, so this is M, L, O, and N. And if I could just give you one very strong piece of advice. When you are doing these problems, draw the picture in your homework, because what you'll notice is as you go, you find out new things, and if you don't mark them, then you don't see what it's supposed to be leading you to, okay? So a proof is just brilliant in that one step leads you to the next one, which leads you to the next one, which leads you to the next one, which leads you to your answer, okay? So if you mark them as you go, you'll see that stuff. If you don't mark them, you don't often see what they're trying to get you to see. Okay, so we're going to mark what we know. So we're going to mark our given information first of all. So it says given LM is congruent to LO. So put a little hash mark, LM and LO. Okay, so those two are congruent. Then it says MN is congruent to ON. Okay, so double mark that because that's a different segment. Then it says angle M is congruent to angle O. And then MLN congruent to OLN. So this angle here, double arc with double arc. Okay. Then think about what they're asking you to prove. They're asking you to prove two triangles are congruent. And what did we say? In order for two triangles to be congruent, all three what? All three sides and all three angles have to be congruent. Well, we are well on our way, right? We have two pairs of angles and we have two pairs of sides that are congruent. So we just have to check, are the third sides congruent and are the third angles congruent? Okay. So here's how your proof would look. Step 1, you take all this information, and if you've written all this out or if it's a test or something, I don't expect you to rewrite that. You may put a box around it and draw an arrow to that one and call it good. Okay, what's the reason for all of that information? Given. Okay, so we know all of that. Now we got to figure out, is our third side congruent to our third side, and is our third angle congruent to our third angle? Anyone want to venture a reason as to one or the other of those being true? Angelina.
LN is congruent to NL.
How do we know that? It's the same segment. Okay, do you remember which property says ln is congruent to ln? Reflexive. I promise you, you're going to see reflexive a ton in this chapter. So look for overlapping figures where they use the same segment, because that should be one of your easier reasons in this chapter. ln is congruent to ln because of the reflexive property. Okay, and mark it. So put 3 little dash marks on ln. Now we know all 3 pairs of sides have been proven congruent. Okay? What's the last thing we need to say then? Yeah, Connor. LNM, yep, angle LNM is congruent to angle LNO. Does anyone know why that's true? Connor.
Third angles theorem.
It's the third angles theorem. If we know 2 angles are congruent, then we know the third angles are congruent, right? So you're just going to say third angles theorem. Okay? So if we mark that, 3 arcs with 3 arcs, now we have all 3 angles congruent, all 3 pairs of sides congruent, so we can say what they asked us to prove, triangle MLN is congruent to triangle OLN. Why? Do you remember what we said on that last one? Definition of congruent triangles. Definition of congruent triangles. Okay? And I cannot tell you enough how helpful it is to mark things, because if you don't mark them, you don't see that, oh, we have 2 of the 3 angles, it's third angles theorem, right? Or, yeah, just the bits and pieces that come into play with this stuff. So mark it as you go on your triangle, and that will help a ton. Okay? Any questions on that? Yeah, Devin.
So if you were given that angle MLN is congruent to angle OLN, then why do we rewrite that angle LN is congruent to? Oh wait,
Because that's a different angle, right?
wait, how?
We were given these guys on the left. That was in the given. This step 3, is that what you're talking about? That's this set of angles, different angles. Yeah, it's always, keep that in mind actually. When you're listing angles with 3 letters, where's your vertex? The middle letter is always your vertex, okay? So this is angle N and angle N versus this is angle L and angle L, or angle, well, that one doesn't have 3 letters, but yeah, so it's always the middle letter is your vertex that they're talking about, okay?